Hey 8th graders! So, many of you have already met my math cats, Callie and Speedy. Well, today I was showing them some math problems at home and something crazy happened. Let me show you. I presented Speedy and Callie with two math problems. The first one looked like this. The second one was also a right triangle. It looked something like this. But both of them had to be solved differently, and Speedy and Callie did not agree on how each of them would be solved. Callie thought that they should use the triangle sum theorem, and Speedy thought, no, we should use the Pythagorean theorem. This is what happened next. That's crazy, right? I thought so. Let's take a peek at the problems Callie and Speedy were looking at. Okay, so let's take a look at this triangle here. Definitely a right triangle because I see the square right here. That indicates it is a 90-degree angle. It is a right triangle. Now, I'm also noticing a couple other things. The numbers are on the outside of the triangle, and we have a variable also on the outside of the triangle. So even without any directions, I know that I'm not trying to look at the interior angles. I'm actually trying to find the side lengths of the triangle, specifically this side length. Why? Because the other side lengths are already given to us. As you can see, that the hypotenuse is represented with 12, and the other leg is represented with 8. So we can go ahead and we can use the Pythagorean theorem to solve for a missing side length. We always represent the legs with A and B, and the hypotenuse is going to be C. It's always represented with C. So let's go ahead and try that out here. We're going to start with writing our Pythagorean theorem. A squared plus B squared equals C squared. And my squares do look a little funky, but those are second to the second power. All right, I'm going to draw my line down the center of my equal sign to show the two sides of my equation. I turned Irish there. We're going to go ahead and we are going to start substituting in the values we know for A and B. For example, I know that the legs are right here, and 8 was one of our values we had for the leg. So I'm going to represent that with A. This leg I'm going to represent with B. And this hypotenuse I'll represent with C because C is always, always, always the hypotenuse. So 8 is going to be A. It's 8 squared plus B squared. Well, we don't know what B is yet. We could either put Y or B squared is fine. And C squared is going to be 12 squared. Now we're going to go ahead and square these numbers. Well, 8 times 8 is going to be 64. We're simplifying. Plus B squared, I still don't know what B squared is. And 12 times 12 is 144. Now what we need to do is we need to use inverse operations to isolate our variable. Our variable is B, and we need to get it alone. We're isolating it. So in order to cancel out any terms on the same side of any equation, we use inverse operations. So this is a positive 64. I need a negative 64. Oops, why did I write 65? I don't know. 64. And that cancels it out. B squared still remains there. Whatever I do to one side, I do to the other. So we have 80 here. Now we're going to need to still isolate B. This is B squared, or B times B. So in order to isolate a variable, we're going to use inverse operations. So the opposite of squaring is taking the square root. So we're going to do that to both sides of our equation. This is going to become B equals the square root of 80. So let's see what the square root of 80 is. I'll pop that into my calculator. In my calculator, I got 8.944279191. I'm going to go ahead and just round that to 8.9. And I can say then that I'll go back and erase those, that B is approximately 8.9. So if I zoom back in here, instead of writing b, we know that it's 8.9. Or we can say that y is 8.9. Yay. It's nice to solve these things. I love it. Smiley face. But wait, there's more. So I cleared the page and I brought up Callie's problem. And it looks like this problem we also don't need directions for, because automatically I can see that on the interior of this triangle, the angles are being presented to me. The interior angles. Well, I have 40 degrees. I know that this is a 90-degree angle. And I know that all angles, all interior angles of any triangle, always have to add up to 180 degrees. So I'm going to go ahead and I'm going to say, well, 90 plus 40 is 130. And then I can say, well, it has to be 180. So I'm going to subtract 130 from 180, and I have 50 degrees remaining. So I know that this has to be 50 degrees inside. I can double check and make sure by adding. That's what I would do. I would say, well, does 50 plus 90 plus 40 all equal 180 degrees? And I just checked, it does. If I add up 50 and 90 and 40, all of them will equal 180 degrees.